Welcome to my projectbazaar.com.
Now we discuss about the product for FPGA based fast and high throughput 2 slow retiming 128-bit AES encryption algorithm. Next we see the abstract for the product. In recent years, cryptographic development has been high priority and challenging research area in both field of mathematics and engineering. One of the main subject in cryptography is symmetric key cryptography, where the shared of key of a certain size will be used in the encryption and decryption process. The advanced encryption standard encryption is an example of symmetric key cryptography. Over the last few years, AES encryption is used to main cryptography application. Several techniques has been proposed in implementation of the AES algorithm on FPGA. The AES algorithm is implemented using the different method and contributions which can be characterized as follows. In the first category of pipeline, sub-pipeline and loop unrolling technique are used in the increasing the operational frequency and throughput. The method of study to second the category include the design of lookup tables and the implementation of byte substitution block. This means S block functions in our the process. In an architecture based pipelining, sub-pipelining and loop unrolling with 7 substations each rounding unit. Furthermore, the composite field arithmetic is employed to reduce the area requirements for overall architecture process. This paper presents a high throughput digital designs of the 128-bit advanced encryption standard algorithm based on 2 slow retiming technique on FPGA. The C slow retiming is well-known optimization and high-performance technique. It can enhance the design with feedback loops and automatically rebalance the register in the design. The C-slow retiming can break the critical path of the design into finer pieces to improve the throughput of the design. The complexity of C-slow retiming on FPGA is to find the best register allocation in the data path of the design, so that by increasing the number of register, reallocation the register to balance the AES architecture be in the best mode and the critical path and optically pipelined and to improved. In this paper, architecture of the AES algorithm to implement the gate level and high speed and breakable structure that are disabled for the 2 slow retiming. The mixed column transformation is to implement the based on multiplication by constant 2 or more module with the combination logic circuits. Next we see the flow diagram for the product. First of all, the data inputs are applied to our the plain text and the key text for our the AES encryption architecture. The AES encryption process mainly considered for the pipeline based architecture. This pipeline mainly consider the 2 slow and retiming process. 2 slow retiming mainly used to reduce the number of register element in overall AES architecture functions. The AES functions generally called for key generation and shifted rows, mixed columns, sub-bytes. These blocks generally assigned for AES operation. This operation to control the feedback logic based on control selection process. This is the overall AES process, and the data and key generation architecture to apply the pipeline based for key generation process. Thus the key generation results to apply the sub-bytes process. These sub-bytes to separate the functions for based on our the 2 slow and multiplying and squaring based constant with sub-bytes architecture functions for overall architecture. Then the shifted rows function to store the register element and to shifting the functions based on the selection logic. This selection logic to control the control unit positions. Then to calculate the mixed columns. These mixed columns to mixing the separate allocation of data functions and to mixing the third positions and second position for overall data functions. This is our the mixed function. Then the key expansion function to create the word function to the feedback logic function. This logic function to apply the key generation architecture results. Then to control unit first based on our mux selection process to be controlled for overall architecture process. This mux selection mainly controlled by the shifted rows, mixed columns, sub-bytes for overall selection process in our final architecture of AS processing results. Next we see the final output for the product. First we run the AS structural designs for Xilinx ISC project lizard. Then to select the simulation process and to run the simulate behavior model for 128-bit AS architecture results. Then we apply the binary result for plain text and the key text function and to process the AS architecture result. This ISM project to simulate our overall process. Then to apply the binary pattern results for plain text and key text functions. Any of the data to apply our architecture. Then apply the plain text and key text and to apply the selection logic for control unit selection based on subbytes and fixed column mixed rows processing. Then to run the time specified on the toolbar function. This is our the input and output results for functions. Then to activate the clocking signal, but the reset function is to be 0, so all of the outputs are to be 0. Then to deactivate the reset function and to apply the clocking signal. Then to create the final output result for 128-bit results for AS architecture. Then close the simulation process and to select the implementation process. This implementation process to describe the what are the logical blocks placed in our overall architecture function. This is our view RTL schematic diagram. This is the RTL diagram to represent the what are the logical blocks placed in our overall architecture. Then the technology diagram. The technology diagram mainly used to describe the what are the logical function and the lookup table input output buffers, then the wire connection based on our overall architecture results. Then go to the design summary process. Then the design summary process to select the synthesis report result. The report results mainly used to calculate the number of area process in overall architecture results and to calculate the processing time for overall calculation for the AS architecture process. This is the sample for key functions and calculate the overall subfiles, mixed columns and shifted rows to separate synthesis report results and to combine the overall AS architecture results for our final 128-bit AS architecture.